Welcome to Chapter 7 again. On page 225, we will be working on application number 74, Yield to Maturity. In this application, we have a firm's bond that have a maturity of 10 years with $1,000 face value, 8% semi-annual coupon, callable in 5 years at $1,050 and currently sell at a price of $1,100. The question is, what are their nominal yield to maturity and their nominal yield to call? So, to be able to calculate the yield to maturity and the yield to call for the bonds, we need to set at first the formulas for both YTM and YTC. So here we have the both formula for the YTC and the YTM. So in this formula, we need the coupon payment, we need the par value, market price, number of years till maturity, and for the YTC, we also need the coupon payment. Instead of the par value, we need the call price, and instead of the number of years till maturity, we need the number of years till calling the bond. So how to set the given? So let's check. Number of years till maturity is 10. Okay, however, we are working on semi-annual coupon payment. It means that the 10 will be converted to 20, which is 10 times 2, because here we have semi-annual payments. So because we have the semi-annual payments, we have converted the n. So it's 20. For the coupon rate, in the given it's 8%. It's semi-annual coupon payment. So the coupon rate is 8% divided by 2, it's 4%. Now, to calculate the coupon payment, we have to multiply the coupon rate by the par value, and we get 40. So this 40 is the one used in the formula. Now we go back to our formula, and we have all the data ready to be calculated. So the coupon payment is 40. Par value is the face value given in this application, it's 1,000. The market price is the selling price of the bond, or what we call also the present value, it's 1,100. Number of years till maturity, it's the number of years that we have converted to take into consideration the semi-annual payments, it's 20, divided by this part. Going to the YTC, coupon payment is the same as the one calculated in the YTM, but instead we need to use a different price, which is a call price. The call price is given here, it's a callable price of 1,050, so we use the 1,050, okay? The market price is 1,100. Number of years till calling the bond, the number of years till calling the bond are 5 years, but we have a semi-annual payment, so the number of years till calling the bond will be now 5 times 2, 10. So we use the 10. It's not the same 10 as the years till maturity. It's the 10 converted by the 5 times 2. And then we continue by applying this part of the formula. So for the YTM, we get a YTM of 3.3%. And for the YTC, we get a 3.25% by applying this part of the formula. Now, because all the components of the formula were used by applying the semi-annual payments, this yield is a semi-annual yield. In order to go back to the annual YTM, we have to multiply the yield that we get from this formula by 2 to go back to the annual YTM. So we get a 6.6%. Same for the YTC. This yield is a semi-annual yield. To go back to the annual yield, we have to multiply by 2 and we get a 6.48%. Now, the first part of the question was to calculate YTM and YTC and then to deduct what return should investors expect to earn on these bonds. Now we all know that bond issuers will take decisions on calling or not calling the bond based on the comparison between YTM and YTC. So let's check here the comparison between YTM and YTC. YTC is 6.48, So it's lower than the YTM of 6.6. In this case, because bond issuers seek lower cost, so they will call the bond, okay, because it's lower for them. So investors would expect the bond to be called and they will earn the YTC. So here, if we go back to the question, what return should investor expect to earn? Investors will earn the YTC because the bond will be called and then it's the YTC that will prevail. Thank you.